Let's go ahead and get started then. I did want to mention just kind of our agenda for the day. So my name is Danielle Golan, as Dr. Jean mentioned. So today we will be providing a presentation about the Lpdac, and then we'll have a question and answer portion. And then I will be leading a walkthrough of the Lpdac website and Earth data search. And then we'll have 10 minutes for a question and answer break session. And then Masa will be taking over and talking about Lpdac tools and services, as well as some walkthroughs with peers. So with that, we'll go ahead and get started. All right, so as I mentioned, my name is Danielle Golan. I'm the Science Communications Lead for NASA's Lpdac. And I just want to thank you all again for spending time with us this afternoon, listening to us talk. We are about to provide you with a lot of information over the next couple of hours. So don't worry, we will be providing slides later on this week after the second half of the workshop is completed. So feel free to sit back, listen, maybe take notes on things that are really important to you, but we will have access to the slides later. Also, as Dr. Hogan mentioned, please feel free to ask any questions in the chat, and during our Q&A sessions, we'll be able to address those at the end of different presentations and demos. All right, so with that, let's go ahead and get started. So first things first, what is NASA's Lpdac? Well, as we've mentioned a couple of times now, we are the Land Processes Distributed Active Archive Center. We process, archive, and distribute land remote sensing data to the earth science community. And we also provide resources to teach users how to apply the data. The Lpdac is a partnership between NASA and the USGS, and we're located at the USGS Earth Resources Observation and Science, or AERO Center in Sioux Falls, South Dakota. The Lpdac was established in 1990, whereas AEROS itself was established in the 1970s. Our archive provides access to 7.8 petabytes of data and extends from 1981 to present, with many temporal ranges in between, including daily, weekly, monthly, yearly, and more. And the data ranges from 1 millimeter all the way up to 5,600 meters in spatial resolution. Now, full disclosure, it is a little unfair to say 1 millimeter. Our millimeter level data is over specific science reserves in Minnesota, Oklahoma, and Nebraska. So if later your research does involve those areas, then I have some really great data for you. But if not, you might be interested in a larger portion of our archive, which starts at that 15-meter resolution. The image on the left shows the world's largest solar energy park in India at a 15-meter resolution, or one of the world's largest. And on the right, we can see a view of the entire Earth in one day from the Swami NPP VIIRS satellite sensor at that 5,600-meter resolution. So with data from the Lpdac, we can see down to solar panels and as large as the entire Earth in one day. And most importantly, everything we're going to be talking about today and on Friday is available to you at no cost. So what types of data are available from the Lpdac? On screen are the currently available types of data. They cover a wide variety of variables, including vegetation, elevation, land cover, and more. And we're also actively adding new data products to the archive every year. So in the future, that might be based on types of data that users are recommending. So if you have any sort of feedback on something you'd really like to see that relates to the land, let us know. And when I say we are actively expanding our archive, I really do mean that. In the past year alone, we've added 13 new data products to the archive, in addition to hundreds of products that have been updated based on their version. So we have all these different types of data. But where do they come from? Well, on screen are our current core missions, as well as our NASA measures and community products. Over the next few slides, I'm going to be going into more detail about our core missions, but I did want to mention some of our smaller measures and community products. These are produced by NASA-funded PIs, and they are also sometimes submitted by the community, like that very fine detailed data I mentioned earlier over specific science reserves. Now, if you are interested in cropland, emissivity, land cover, land surface temperature, LIDAR, or phenology data, or if you're interested in historical research, so data from the 80s or 90s, then I definitely recommend looking into our measures and community products. But now let's dive a little deeper into our core missions. So first we have Harmonized Landsat Sentinel-2, or HLS. HLS produces a consistent harmonized surface reflectance product from Landsat 8 Operational Land Imager, or OLI, and Sentinel-2 Multispectral Instrument, or MSI data. There are plans to incorporate Landsat 9 into this data soon. These combined measurements do provide global observations of the land every 2 to 3 years at a 30-meter spatial resolution. And HLS is our first data set that's fully in the cloud as the Lpdac works towards moving our entire archive to the cloud. We just recently released a science-ready version 2 of these data. So we have the L30, or the Landsat product, and also the HLS S30, or the Sentinel product. As I mentioned, these data are available across the globe, and they will be available from April of 2013 to present once historical processing has been finalized. This is a relatively new data set, so we are still historically processing the data. Currently, the S30 data are available from about mid-2020 to present, and the L30 recently completed its historical processing, so those data are available from April of 2013 to present. And again, both of these data sets are available at a 30-meter resolution. And on the Lpdac website, we have several tutorials and scripts to get you started with the new data. These are scripts in R and Python. We also have some processing, exporting, and reformatting scripts, as well as a bulk download script. Next is the Global Ecosystems Dynamic Investigation, or JEDI. JEDI is a venture class mission attached to the International Space Station, or the ISS. JEDI is a full waveform LiDAR sampling mission that aims to characterize ecosystem structure and dynamics to improve quantification and understanding of the Earth's carbon cycle and biodiversity. JEDI precisely measures things like canopy cover, canopy vertical structure, and surface elevation. And JEDI is really the first of its kind to provide high-resolution, laser-ranging observations that are optimized for LiDAR measurements of the Earth's forests and topography at the highest resolution and densest sampling of any LiDAR instrument in orbit to date. We offer 3 JEDI products: the geolocated waveforms, geolocated elevation and height metrics, and canopy cover and vertical profile metrics. Spatially, JEDI is available across the globe between the latitudes of 51.6 degrees north and 51.6 degrees south, and the data are available since March of 2019. We are currently releasing these data in batches, so we have data that's available through January of 2022, but more data will be available soon. Now, downloading and processing these data can be a little complicated to work with. Each time we have a new version of the data, it gets a little bit easier, but we do still provide several tutorials and scripts on our website to help with downloading and processing the data. So spatial querying, getting started in Python, and also accessing and analyzing the LiDAR data for vegetation studies. We also have Ecosystem Spaceborne Thermal Radiometer Experiment on Space Station, or EcoStress. This is another venture class mission attached to the International Space Station. EcoStress aims to answer questions primarily about vegetation, water availability and water stress, and drought and agricultural vulnerability. There are currently 14 EcoStress products that are available from the Lpdac. They're divided into 4 different levels. So level 1 includes our geolocated parameters, calibrated radiance, and resampled radiance products. Those are used to generate level 2 products, including the land surface temperature and emissivity and a cloud mask. In turn, those are used to derive the level 3 evapotranspiration products and some ancillary data QA flags. And then we also have level 4 evaporative stress index and water use efficiency products. EcoStress data are available from July 2018 to present. And spatially, EcoStress covers CONUS, as well as 10 key biomes and agricultural zones, and around a dozen selected FluxNet sites. The data are provided at a 70-meter resolution, except for a couple of products that are produced by the USDA, which are available at a 30-meter resolution. Now, the temporal resolution is variable. It depends on the orbit of the ISS, but generally you can expect to have an observation every 1 to 5 days. And we do have several data tutorials and even a workshop for working with EcoStress data on the Lpdac website. Now, one of our newest sensors is VIIRS, or the Visible Infrared Imaging Radiometer Suite. VIIRS is currently aboard the SWAMI National Polar Orbiting Partnership, or SWAMI NPP, and NOAA 20 satellites, and it will be on several more additional Joint Polar Satellite System, or JPSS satellites in the future. VIIRS was designed to extend and improve on the AVHRR and MODIS missions. The Lpdac currently distributes 125 land data products, with more coming soon with version 2, as well as NOAA 20 version 2 data being released in the next couple of months. These products offer similar products to MODIS, including albedo, BRDF, burned area and fire, FPAR, LST, LAI, and more. VIIRS data are available from 2012 to present, so a decade of data, and they're available across the globe. Now, these data are available as 500 meter, 750 meter, 1000 meter, and 5600 meter. Those are resampled from a 375 to a 750 meter bands to match that MODIS data. So with these data, we're seeing changes on the Earth at a larger scale, less details, but over a larger area. The temporal resolutions are similar to MODIS. They're available as daily, 8-day, 16-day, monthly, and yearly composites. And we also have several tutorials and even an ArcGIS toolbox to work with these data. So we've been talking about MODIS, as I mentioned, VIIRS. So now let's cover MODIS, or the Moderate Resolution Imaging Spectroradiometer. MODIS is aboard the Terra and Aqua satellites and is one of the most popular sensors that we offer. With MODIS, you can observe the Earth every 1 to 2 days, and it's used to study large-scale global changes around the Earth, like VIIRS. The Lpdac specifically distributes MODIS land data products, but there are several other ocean and atmospheric MODIS products, as well as VIIRS products as well. We currently offer both MODIS version 6 and the recently released MODIS version 6.1 data products. So we do have a lot of data for MODIS right now. If you have been using MODIS version 6, we highly recommend switching over to MODIS version 6.1 if there is an equivalent data product available. With these data products, you can study a variety of topics, including vegetation, land cover, land surface temperature, emissivity, fire, and more. And these data are available from 2000 to present, so we have a pretty long record for users that are interested in several decades worth of data. And they're available across the globe and come in a variety of spatial and temporal resolutions. And as I've already mentioned several times, we also offer several e-learning items to work with MODIS data as well, including that Python toolbox I mentioned earlier. And finally, we have ASTER, or the Advanced Spaceborne Thermal Emission and Reflection Radiometer. ASTER is a cooperative effort between NASA and Japan, and it's located on the Terra satellite like MODIS. ASTER is a little different from MODIS or VIIRS. It is taskable, meaning it needs to be told to turn on, and it covers a much smaller amount of area, but over much finer detail. This is useful for things like making detailed maps of land surface changes, observing more localized changes, and it's also used frequently for elevation with the Terra ASTER Global Digital Elevation Model, or ASTER GDEM data product. We have 18 different land data products from ASTER, including that elevation product I mentioned, a precision terrain corrected product, as well as some temperature and emissivity products and more. Like MODIS, these data are available from 2000 to present, and they are available across the globe. Now, as I mentioned, ASTER has that much finer detail than MODIS or VIIRS. It has a spatial resolution of 15, 30, and 90 meters. Now, since it is taskable, the temporal resolution is based on when the satellite is tasked, but some areas like volcanoes are tasked regularly. And on screen are some of the tutorials we have for working with ASTER data. We have several tutorials available in R, as well as a couple of data prep scripts that kind of prepare the data for you. All right, so now that we've talked about the data, I wanted to provide some brief data examples of wildfire and agricultural applications, since I know that's what a lot of you are working on. So first, let's observe the Dixie Fire in California using data from the Lpdac. The Dixie Fire occurred from July 13th to October 25th of 2021. It was the largest single wildfire in California's history and the second largest wildfire overall when counting complex fires that encompass multiple fires. The Dixie Fire went on to burn an area larger than the US state of Rhode Island. And looking at some statistics, it was one of the most expensive wildfires in US history, if not the most expensive. And some initial research stated that it started after a healthy tree fell on a down power line, or fell on a power distribution line. So on the screen is a map showing the burned area data from MODIS for the first month of the Dixie Fire. The base map is a Suomi NPP VIIRS surface reflectance image from around the time of the fire. So we can see where the fire began as it spread northeastward. So you can kind of see from the brighter teal as it shifts into kind of the lower blues as it spread. And then it split into two main branches during the month of August. So we can again watch as the fire spread through the burned area and spread even further out. But overall, during the month of September, it was a lot more contained due to firefighting efforts and weather. The fire was not actually large enough to be observed by MODIS during October, but here we have a map of July, August, and September where we can clearly see where the fire began and how it moved as we go from light to darker shades. Now let's observe the same fire using the Terra MODIS 8-day thermal anomalies and fire data product, the Mod14A2 product. Now when I say 8-day here, I mean this is an 8-day composite of the pixels with fire confidence. So we can see again where the fire started. We can also see that during this time frame, there was a separate fire that was not part of the Dixie Fire, and it ignited, or it was extinguished pretty quickly during this time frame. I think in the next 8 days, we won't see it anymore. So we're just focusing on this fire right here. So with the fire data, we can again start to see that the fire split into those two main branches. And we can observe as it grew and spread. And until September, when the fire was more contained again due to that firefighting and weather conditions. By mid-September, the southern branch was no longer detected by MODIS, so we do still have a little bit of the northern branch. And then by early October, the fire was small enough to not be detected by MODIS. So when we turn on all of the fire data during this time period, we can observe the extent of the fire. So running through that one more time quickly, we're going backwards, and then I'll show you again. Whoa, sorry about that. I'll show you again going forwards. So you can definitely watch where the fire grew and spread and changed over time. On the Lpdac website, we have even more examples of how various data are successfully used to conduct fire-related research, whether that's using MODIS NDVI data or JEDI Plant Area Index as remote estimates of fuel load, or how the ISS eco-stress data is used to study evapotranspiration and vegetation recovery after a fire, which we actually have two really awesome podcast episodes on this topic that I highly recommend, where researchers are talking directly about their eco-stress research. I'll point that out during the website demonstration later in a little bit, where you can find those episodes. And we also have, like the MODIS example I just showed, a VIIRS equivalent product that's been used to also monitor how fire evolves over time. And these are all examples based off the Lpdac website. So again, as I show the website demo, I'll show you where you can find these examples so you can read and learn more. Now, in the past, data from the Lpdac has also been used in a variety of ways to study agriculture. Now, for the sake of time, I'll mention a few agricultural applications we've covered on our website, but I do highly recommend visiting the website to see even more examples. So we have data from the Lpdac has been used to map soil respiration, as well as forest productivity. It's been used to study food insecurity and vegetation and browning and greening trends. It's been used for drought detection and early mitigation to mitigate crop loss from drought, as well as to study a variety of methods for studying crop yields, to study things like beekeeping, different types of soybean crops, just to kind of predict crop growth as well. And it's also been used to study the impact of natural disasters on the crops. Again, I recommend visiting our website to learn more, to see these actual data examples and read about them. And in a few minutes, I'll show you how to access that information. Now, I've talked a lot about the data, so let's talk about some resources you can use to work with the data. So we have a wide variety of resources for data, including videos, data tutorials, previously recorded webinars, data examples via stories and science articles, images, and more. And now we even have podcasts. We've teamed up with the USGS Eyes on Earth podcast to create several Lpdac related episodes. And I'll be showing all of this later today in the Lpdac website demo. We also have our data tutorials that teach you how to work with the data, as well as data prep scripts, which will do some of the processing for you. We like to say that our data tutorials teach you how to fish, and our data prep scripts do the fishing for you. And later in the day, NASA will be providing more details on our data tutorials. So now that I've covered the various types of data and resources, how can you get all of this data? Well, we offer a wide variety of methods. If you're an experienced user and you really just want to get your hands on the original source files of the data so you can just get to work, then I recommend using Data Pool. If you're an R or Python user, I recommend using DAAC to disk. I also strongly recommend attending Aaron's talk later on Friday, where he'll be going into a lot more details about using Python with Lpdac data. If you prefer to see a preview of what your individual scenes look like, maybe you want to make sure everything you're downloading is within your study area. You might not know the HV grid system for Modus, for example, or maybe you just want to look at what other data is available in your study area. Then I recommend using NASA's Earth Data Search, which I will be providing a demo of in a few minutes, or the USGS Earth Explorer. And if you want a tool that allows you to really dive in and do the customization for you, lets you explore your data values before you download anything, then I definitely recommend Appears, which NASA will be providing a demo of later today. So that brings me to the end of the Lpdac presentation portion of the day. At this point, I see we have a couple of questions in chat, so I'm happy to answer those at this point. If you do think of a question later on, please feel free to contact our in-house user services team via the contact information on the screen. You can also hop into the Earth Data Forum to talk with other data users about your data experience or about your research or any cool things you're noticing with the data. And we also have the Lpdac listserv. So if you want to be the first one to know about new products or resources, I send out a listserv message about once a month with that kind of information. So again, I want to thank you for listening to me speak. And with that, we'll take any questions.
Yeah, Danielle, I don't know if we have any questions in chat. We can open it up for a few minutes if anybody wants to ask. Feel free to add them to chat as well. That was mostly me adding links to chat if you saw anything go through.
Perfect. Thank you, Aaron. All right, if we're not seeing any questions, at this point, we could move on to the demonstration portion. So let me pull that up really quick. All right, so if we have no more questions, let's see, someone asked if we can have a link to where the posting will be recorded. I'm assuming Dr. Hogan will be sending that out at the end of the workshop next week.
Yes, that's correct. By about Monday or Tuesday, I should have that up on our IGIS YouTube channel, and I will send a link out to everybody that's registered for the workshop.
All right, perfect. All right, not seeing any more questions. I think we're at a point where we're good to move on to the demonstration portion. So, as I mentioned, the Lpdac website offers a wide variety of information on sensor details, information on our 580 data products, as well as tools and resources you can use to access and work with and see how the data are being used in the science world. Now, the first thing to know about the website is the link, lpdac.usgs.gov, and I believe Aaron will throw that in the chat for me, although I see he has already done that, so perfect, thanks Aaron. So this link will take you to our homepage. From there, you can see our most recent data and action stories. You can see our most recent news and events about the data sets. We also have our collaborate section with us, so if you're interested in following NASA Earth Data on Twitter or on Facebook, or if you're interested in that Earth Data forum I mentioned earlier, or the Lpdac listserv. We also have a contact button in case you have any questions that you need to ask the Lpdac. From the top of the website, we have this blue bar that has several different options. We have About, Data, Tools, Resources, Contact, and a general search. Under the About section, we have just some general information about the Lpdac. We also have our news archive. So this provides all of the news announcements we've released. It is filterable. So let's say you have a favorite data set, maybe HLS. You can just type in HLS, hit enter, and then that'll provide you with news announcements about HLS. I definitely do recommend checking our news announcements. If we get any word from PIs that anything about the data needs to be reprocessed, anything like that, we'll make sure to post that on the news announcements so you'll be able to stay up to date with the data you're working with. From the data section, we have Get Started with Data, the Search Data Catalog, and our data citations and policies. All of the data from the Lpdac is available for no cost to users, and there's no restrictions on how you can use the data, no redistributions, restrictions, anything like that. So going ahead with Get Started with Data, we have our collection overview section. This provides a lot of information about all the data sets that I mentioned earlier. So MODIS, ASTER, VIIRS, EcoStress, measures, community, all that great information. This is kind of the great place to just go to when you just want to get started to learn about the data. So under these sections, we have MODIS. We'll have kind of a description about the sensor or data set. We'll have a link to that search data catalog that I mentioned, pre-populated. And we will also, for our main sensors, have the MODIS overview page, or have the overview page. So here's an example of the MODIS overview. And here I can see all of the information that I could really want to know about MODIS itself. So an introduction to the sensor, the naming conventions. This is a really great kind of cheat sheet for users. With a lot of our data sets, when you have the file name of the granule, that tells you a lot about that information. So it tells you the product short name, in this case, mod 14, which is a Fire product, one of the ones that we looked at earlier, the Julian date of acquisition, the hours and minutes, the collection version of the data set, the Julian date of production, so when the scene was created, as well as the data format. If you are downloading a tile grid product, it will have that HV tile for you, so you can know exactly where this is located on the world. You can cross-reference with that HV grid. We also have the long name, so that'll provide some more information about the sensor, the geophysical parameters or the keywords, the temporal resolution, processing levels, the coverage, the spatial resolution, the sinusoidal grid, and then also the collection version. Below that, we have information on temporal and spatial resolutions, as well as the tiling system for that sensor. So in the case of MODIS, it's the HV grid I mentioned earlier, as well as the data processing levels, and also some specific information about the spectral bands. And then the metadata information, golden month products if available, and then tools and services that work well with that data. So the collection overview pages, the overview pages are just really helpful when you kind of want some of that basic knowledge. From the missions page, we also have decommissioned documentation. If for some reason you're doing a historical review of MODIS data or ASTER data, we'll have one in the future. This is a place where we have previous user guides, previous ATBDs from versions that did not have DOIs. So going to the MODIS products table, this is going to take me to the search data catalog pre-filtered to show just MODIS products. So I can either see this as a list view. So I have my short name, the collection, the keyword or the science keyword that relates to the data, the spatial resolution, and the temporal resolution. Or I can go to the card view, and that'll show me kind of a preview of the data, that short name we mentioned, the long name, the collection, as well as that science keyword, and also any associated tools with the data. Now let's say that you just want to go straight to search data catalog. So we'll start fresh on our search data catalog page. We can see that we have 580 results. So I'm going to start filtering this down a little bit to find the Mod 13 Q1, one of our MODIS vegetation products. It's one of our most popular products, so I wanted to show off the DOI landing page for that specific product. So I'm going to go ahead and type in, let's say, vegetation. And that's going to start filtering down this table to vegetation data. My temporal range, let's say my study area is recent. So I'm going to say January 2021. And then let's just go ahead and say today. And then I'll click apply. I can also filter down my collection. So I know I wanted the mod 13. So that's Terra Modus. I also like to always work with the most recent version. So I'll filter down to Modus 6.1. We do have several different keywords that relate to vegetation. So I will pick the vegetation indices product. And then we also have our spatial resolution. I'm going to pick this 250 meter product, and that's going to filter me down to just the product that I was most interested in. So I'm going to go ahead and click on this image, and that'll take me to the DOI landing page. Now, the DOI landing page, we have one available for every single product that we distribute in our archive. It's really a great page to go if you just need some information about the data. It's kind of the first place to really start for that specific data product. So again, we have that short name, the long name, the version number, and also the PI of the data set. In the background, we can kind of see a preview of what this scene might look like somewhere on the earth. Then we have these nice row of buttons. If you click on documentation, this is going to bring up the user guide, the ATBDs, file specifications. Sometimes we have quick links for these documentations. These are really just documentation we typically either create or get from the PI that provides kind of that really foundational and background knowledge about the data set. We also have our using the data button. So this provides e-learning, data in action, as well as publication examples of the data. So publications, that's going to be a list of publications of people that have cited or mentioned this data set. The data in action are stories that our staff writes. A lot of those use case examples I gave earlier come from our data in action section. And then our e-learning materials I'll show you later, but this has a video about citing data. We also have the access data button. This will tell you the tools that you can use to work with the data. So in this case, we have several tools that work with Mod 13Q1. On the left-hand side, we have a direct link to the tool. We have a list about what kind of functionality that tool provides, a description of the tool. And on the right-hand side, we have a button that'll take you directly to the tool, and even if possible, to that data specifically in the tool. We also have a citation button. If you are working with data from the Lpdac, we would love for you to cite it, please. That definitely helps us find your paper. It helps other scientists or students find your paper when they're looking for that specific data product. And it also just really promotes the data. So we went ahead and created a handy dandy citation generator. So I can select my citation style in either APA or Chicago, and then I can just copy my citation, paste it right into my research paper, and then it's been perfectly cited, so it'll be easy for other students or researchers to find your paper. We also have a related product section. This provides the search data catalog pre-populated with data that kind of relate or are similar to this data set. And again, these options are available for all of the different data from the Lpdac. Below that, we have a description of the data product. And below that, we have our characteristics section, which has improvements or changes from previous versions. So from version 6.1 to version 6. We have information on product maturity and validation. We have some collection and granule information, so kind of getting into some of those nitty-gritty details. So the number of science data set layers, we have 12. The pixel size, 250 meters. The file size, temporal resolution, coordinate systems, all kind of just key information. Below that, we have the layers, which are going to be spelled out. So we have the science data set layer name, a description of that layer, the units of that layer, the data type, the fill value, if there's a no data value, what the valid range is for that layer, as well as any scale factor that needs to be applied. Below that, we have information on product quality, as well as if there's any known issues with the data. So as you can see, the DOI landing page is really going to provide some of that key information about the data set. On the website, we also have this tools section. And I go ahead and click on View All Tools. And this is filterable as well based on functionality. So if you're looking for a tool that provides, let's say, browse in image previews, you can click on this button and that'll filter us down to the NASA Earth Data Search and the USGS Explorer. This will also provide kind of a brief little introductory sentence about this tool, as well as what the functionality is, and then either a button to launch and go straight to the tool, or a button to provide more information about the tool. There we do have the similar button feature as the Doi Landing Page, so documentation that relates to the tool, examples of how the tool can be used or has been used, as well as a citation for the tool. Under our resource section, we have a wide variety of options that I kind of mentioned earlier. So we have our e-learning section, and MASA is going to go into e-learning pretty intensely later on today. So I'll just kind of highlight that we do have presentations, data tutorials, video tips, and webinars. And this is also filterable. So if you just want a data tutorial, and let's say maybe we're only interested in HLS tutorials, that'll filter down the page to just HLS related tutorials. Under resources, we also have our outreach materials. If you're a professor or if you're kind of putting together a website or putting together a presentation, maybe just for your class, this provides a lot of different graphic images, videos, and fact sheets that are free use. You can reshare them, you can add them to any sort of presentation that you would like. And that also links to where they were shared on social media originally. So we just kind of like to be able to kind of have all of our social media in one place so that people can see it if they're kind of interested maybe in something like, what does a turkey farm look like? From the resources section, we also have our FAQs, so frequently asked questions that we receive from users. Our data and action series. So again, these are articles that our staff writes. I believe we're at 111 articles now. And the map above kind of shows the location of all of those articles. If you click on one of the dots, it'll tell you a link to read the story, an image kind of preview of the story, the themes and the data types that relate to that story. And the table below is also filterable. So let's say if I wanted to look at those agricultural examples I mentioned earlier, I can just type in agriculture, and that'll filter down to stories that relate to agriculture. Under resources, we also have the publications table that I mentioned earlier. So remember, the DOI page will link to this table, and I'll link to the table pre-populated. So let's say if I'm interested again in that mod 13Q1 data set, I can type in mod 13Q1 or use that link on the DOI landing page, and that'll show me papers that have used that mod 13Q1 product. So it's a really great way to be able to see how other people are using the similar data products to what you're using. We also have the Lpdac Dictionary. This just provides common terms that you'll see across the website and what we mean, or common acronyms and what we mean by those. And then finally, we have our podcast section. That's what I mentioned earlier. We're working with the USGS Eros Center on their Eyes on Earth podcast. And we've created several episodes that relate to eco-stress data, HLS data, MODIS data, and also accessing data in the cloud. These are available on Apple and Google Podcasts. So you can just search for Eyes on Earth, or you can come to our website and we'll provide links to the podcast itself. But they're definitely really interesting episodes. So if you are interested in, say, global water use or fire, I think we had one on exotic annual grasses. I definitely recommend. They're worth a listen. They're typically less than 20 minutes, so they go by pretty quickly, and I think they're really interesting. Also on our page, we have our contact information. So again, if you want to reach out to the Lpdac staff, you can click on the contact information. And then we also have this magnifying glass for a general site search. So say I wanted to search for information related to California on our website, I can just type in California, click on the magnifying glass or hit enter, and that filters to the different types of content on our website that relate to the word California. So that kind of concludes the demonstration of the Lpdac website. We do have a wide variety of other features that I didn't really highlight too deeply, so definitely go and check it out if you are interested. And if there's any questions on the website, feel free to throw them in the chat. And then if not, we will get moving on the Earth data search portion. All right, Maggie, I'm excited that you like the citation resource. I think it's been really great. And I love being able to find people's papers for that publications table because of that citation resource. So definitely recommend users use it.
Yeah, I want to copy it. I love it.
Perfect. All right, Earth data search demo. So moving right along. As I mentioned, NASA's Earth data search is a great tool to use when you want to make sure your data is within your study area. You want to see a preview of your scene if available, or maybe you just want to see what other types of data are available in your study area during your study period. So you can either access Earth data search by going back to that tools section on our website and finding Earth data search, or you can type search.earthdata.nasa.gov, hit enter, and that'll take you straight to Earth data search. Now, the first thing to know about Earth data search is you will have to log in with your Earth data login account. Don't worry if you don't have one, they are free to create. I think everyone has been creating one for this workshop series, but if not, you can click on this Earth data login button, and that'll provide either a prompt to create your account or it'll log in for you. Now, if we are just getting started in Earth data search, there are a wide variety of options to kind of start off filtering down collections. For those that are going to be attending Aaron's portion of the workshop on Friday, I definitely want to highlight the available from the AWS cloud, because that'll show you all of the different cloud resources that are available within Earth data search, cloud data sets. There's also science keywords, platforms, instruments, a wide variety of information if you're kind of going at this alone. But since I'm here, I'll kind of walk us through Earth data search. So for today, let's go ahead and look at HLS data over California for the past 2 years. So first I'm going to type in, let's say maybe I don't know the name HLS, but I know I want surface reflectance data. So I'll go ahead and start typing in surface reflectance and hit enter. And that's going to filter Earth data search down to surface reflectance data products. So we have 105 matching collections. That's a lot. So let's keep filtering down. I said that we were looking for the past 2 years. So I'm going to go ahead and click on this calendar icon. And then I'm going to change my start date to, let's say, 2020, January 1st. And then just to make it easier, I'll say today. Now, if you are studying a reoccurring season, so maybe you're just interested in fire season, you can click on reoccurring and then just change to the dates, months, and specific years that you're interested in. So that way you won't get all of the data that I'm about to get. You'll just get the months or days that you're interested in. But I'm going to go ahead and click on apply. And now I'm going to drag and move my map over to California. I'm going to use my mouse to zoom in. There we go. All right. And from the left, we have this crop icon. So this is going to set my spatial settings. So I can either draw a polygon, a rectangle, or a circle. I can upload coordinates for a point, or I can have a file. I can upload a shape file, a GeoJSON file, a KML, a KMZ, if I had one of those of the state of California. For today, for time-wise, I'm just going to draw a quick little polygon. Obviously, if you're doing serious research, you'll definitely want to upload a shape file, but I'm going to go ahead and draw my polygon just for the demonstration purposes. So I'm going to click and add my points around the state. Make sure we get the islands, and then I'll keep adding points to the top, and I'll click on my first point to close my polygon. So now this is going to filter data down to surface reflectance data during our time period over California within this polygon. On the right-hand side is also similar feature functionality. So if you want to draw a polygon, rectangle, circle, upload a coordinate, you can use this side button instead of this top left if you're interested. So now I see we're down to 548 matching collections. I can see HLS is down here, but let's pretend maybe it wasn't. I'm going to go ahead and sort by relevance. There's also the option of sorting by data usage or most available recent data. I'm going to go ahead and sort by relevance. And then I see my HLS data here. I can see that I have 9,535 granules from 2013 to present. I have a little sentence about HLS. I have these nice little badges. So the orange one is telling me that this supports advanced mapping visualizations. So I should be able to see HLS data on the map. This gray one is telling me that this is HLS L30 version 2 data from the Lpdac. This is the data set I'm interested in. So I'm going to go ahead and click on it. And that's going to pull up all of my granules. Now, let's say, since I've never worked with HLS before, maybe I just want to download a couple of granules so I can kind of get a feel for what the data is like before I download all 9,535 granules. So I'm going to go ahead and click on these plus signs to just add a scene. Let's say maybe I add a scene by accident I don't want. You can easily just click on the minus sign and that'll remove it. And I can also start to see these boxes on the map showing me where those scenes are. And here I also have kind of a preview of the scene. So I can kind of see a preview with that browse preview that we were talking about earlier. And that'll also show up here. And it should be showing up on the map here, kind of showing a preview within those scenes. I'm not exactly sure why it's not right now. I do believe earlier it was a little hard to see based on the color of the base map, but you should be able to see the data preview. Now, let's say that you're at lunch right now, or you're about to go to lunch, or maybe a colleague has asked you a question, or maybe you have to go to class. You can always save this project and come back with your Earth Data Search parameters already filled in, so you don't have to start fresh. You can click on this little save icon in the top right. I'm going to name this project HLS California, and then I'm going to click save. And so now I can go to class, I can go to lunch, I can visit Earth Data Search later, and under my name, I have saved projects. I can click on that and that'll take me exactly back to this project. So I'll be able to find that HLS California project on my list. That'll take me right back to these parameters already filled out. If you also are interested in subscribing to the HLS data, you can click on the subscription button. Now, this will send you an email when there's any new HLS data within your polygon, and then you'll just have to come back to Earth Data Search to see the data. All right. Now, let's say I did know that I wanted maybe that HLS S30 data too. Instead of typing surface reflectance, you can also type in the short name of the data if you know it. So I'll type in HLS S30. That's going to bring up this HLS S30 product here. So I'll go ahead and click on this product. One thing I did not mention, on the left-hand side, you can also filter down granules. This is really great if your granules have the option like night and day scenes, if you only want daytime, or if you want to filter, sometimes they'll have cloud coverage. So definitely check out this section to filter down granules. But for right now, let's go ahead and click on adding a couple of these granules, and you can kind of start to see some of the previews are popping up. Again, they're a little hard to see compared to the base map, but I'll go ahead and add a couple of granules. And then there is one other thing I want to show you in Earth Data Search. There is a customization feature. I'm going to go ahead and type in Jedi. We'll look at some quick Jedi data over the study area as well. I'll go ahead and select the Jedi level 2B. And I'm just going to add the first granule since I just want to show you the customization feature. So now once I've had my granules selected, I'll click on download, and that's going to take me to my HLS project. So here I can see the products data sets that I've selected. If I click on those, it'll show me the granules I've selected. I also have information on my file size, how many collections I'm using, how many granules I'm downloading. Now Jedi offers that customization feature, so I'll click on edit options. And then I'll select customize. And then below that, I have ways to spatially subset, temporally subset, and band subset. So let's take a look at the center beams of Jedi. As I mentioned, Jedi is on the ISS, and it provides kind of that laser technology. So we have our different beams. And so here I can choose if I want, maybe say all of these layers, or if I know I only want a handful, I can select, let's say, the quality flags, the plant area index, maybe this elevation, and then I can click done and then click on download data. Now, if you don't know what those words meant that I was clicking on, you can go back to that Doi landing page and check out the layers, and that'll kind of spell out what those names mean. So now I'm going to go ahead and click on download. And then I can see my download status. So HLS data is from the cloud. It's complete right away. We weren't going to customize any of that. So I can see that data right now. I can see my Jedi data is being created. Earth Data Search is working on customizing that data to just get me those layers that I wanted. Below that, we have links to those DOI landing pages that I showed you before. If I click on this drop-down arrow, I can see my actual data. So with the HLS cloud data, I have several options. I can either download my data as HTTPS URLs, so I can just individually click on one of these links and download that layer. Since this is cloud data, you can also access these data assets while working in the cloud using the S3 URLs. And Aaron will talk about that a little bit more during his presentation on Friday. But that's pretty much the demonstration of Earth Data Search. It's definitely a great tool, as I mentioned, if you want to see a lot of different data sets. You know, maybe you've always been working with one specific MODIS data set. It can kind of help you find other VIIRS ones that might work in your favor. But I really do enjoy working with Earth Data Search once you kind of get the hang of how to use all the functions and features. But with that, let's see if we can look for any questions in the chat. Saving the project is definitely a great feature. I agree. It's very helpful if you just need to come back later and revisit. We have, is it possible to download a specific shapefile rather than the entire scene? So Earth Data Search does not provide that capability. I believe MASA will be talking about appears, which with appears, you'll be able to upload a shapefile and it will crop your data to that shapefile. So MASA will be showing that in a few minutes. But those are some great questions. Are there any other questions from the group? All right, not hearing any other questions. I think at this point we can take our quick little break, get some water, kind of reset, and then we will have time to work with MASA and listen to MASA speak.
Hopefully you guys are back from your break. I wanted to thank you all again for attending today. My name is Masa Jamie, and I'm a remote sensing scientist working as a contractor to NASA's Lpdac. Daniel provided an overview of Lpdac and Lpdac data missions. She also briefly talked about the tools and resources available through Lpdac. In this talk, we are going to take a closer look into tools and resources that are available for accessing and working with Lpdac data.
Masa?
Yes.
Or Danielle, if you're still available. There was a couple questions in the chat. One was, is it possible to download specific shapefiles rather than an entire scene?
Yeah, Danielle touched on that a little bit. So you can submit a shapefile or GeoJSON file into Earth Data Search, and it will identify kind of the intersecting boundaries of the granules that you're searching for. But you can't, I'm not 100% sure on this. For the majority of data products, you cannot clip to the shapefile boundary. There are some services that are a little bit more advanced for specific products that allow you to do some clipping like that. But for Lpdac, I don't think we have anything set up that would allow you to do that from Earth Data Search. But appears, which will be something that NASA covers, does allow you to do that. The typical data latency for our data products, it varies. I think I'm trying to look at some of the MODIS and VIIRS data. I think they're inside a week latency. HLS tries to be 2 to 3 days, I think, is what they try to be for latency. EcoStress, it depends. But I think they're also kind of inside a week for their latency. So it is kind of data collection specific.
Very good. Yes, that's a tricky question. Thank you, Aaron.
Go ahead, Massa.
Okay, so as you know, there are various ways to access data distributed by Lpdac. Earth Data Search provides access to all DAC data via a web-based map interface, and Daniel will show you how to search and download data using this tool. Similarly, Earth Explorer, developed by USGS, provides a web-based map interface for searching, exploring, and downloading data, and includes data collections that are distributed by Lpdac. Using Data Pool, you can access the data you need via HTTPS links directly. You can also use the curl or wget to bulk download your data from Data Pool. DAC to disk utility is also available as a script for bulk download. Using OpenDAP, you can share data more easily, and you can also limit your selection to how many pixels you desire and get the time series aggregation of your area. And Appears, which is one of our most popular user-friendly tools, enable you to customize data and let you explore your data values before you download anything. Appears is an easy-to-use web application interface for subsetting data spatially, temporally, and by band or layer. Appears also provides some basic output options to help you spend less time searching for, downloading, and processing data, and more time focusing on using the analysis-ready outputs for your research or application needs. Appears also provides interactive visualization of the data for your region of interest and decoded quality information. It also provides the summary statistics and the ability to bulk download analysis-ready outputs. Later in this talk, we'll dive into a demo to show you how to submit a request, view the content of your request, and download output files using Appears. Another resource that you can find under Lpdac tools is data prep scripts. Data prep scripts are command line executable R and Python scripts that can be used to download data or perform basic data processing functions such as georeferencing, reprojecting, converting, and reformatting data. All scripts are available for download from an Lpdac user resources Bitbucket code repository, and each have a README that provides information on how to set up your work environment and how to execute the script from command line. You will be able to use this script and execute them while you don't need to have a deep knowledge of Python or R. You can view the full list of our data prep script from the Lpdac website, but here I will highlight a few of them. If you want to download a large amount of data from Lpdac data pool directly, you will need to navigate through folders and find the data you're looking for one by one and download them. This could become very time consuming, but using how to access Lpdac data from data pool script, you can get the text file of your granule URLs and simply download all of your granules locally. HLS is one of our first data products distributed directly from the cloud. So we have scripts for subsetting, processing, and exporting HLS data, in addition to a script that allows you to bulk download HLS data. Using the data prep script that are available for JEDI data, you can find JEDI data that intersect with your region of interest in R and Python. And if you don't know how to work with the hierarchical data format, you can also convert your data into GeoJSON that can be loaded into GIS and remote sensing software. EcoStress version 1 includes data sets that are being distributed in a SWOT format. So we have a data prep script that enables you to convert your SWOT data set into gridded geotiffs and start your work. Next, we will have a demo of Appears. In this demonstration, you will learn how to submit an area and point sample, how to view the content of your requests once they are processed, and how to download your outputs. I'm using one of our data in action stories from Lpdac website as an example to show you how to extract an area sample. This study is looking at persistent vegetation graining and browning trends related to natural and human activities in the Mount Elgin ecosystem from 2001 to 2018. They used the Normalized Difference Vegetation Index, or NDVI, from Terra Modis Vegetation Indices, or MOD 13Q1, that is distributed by Lpdac and is available in Appears. They also looked at the combined Terra and Aqua Modis Annual Land Cover Type, or MCD12Q1 data products. This data set is also available in Appears. So now let's jump into a demo of Appears. So here's the link, and this is Appears. Sorry about that. Okay. Does anyone know how can I just remove this tab from here?
I think I might be able to request remote control, and then I can maximize for you.
Okay. Okay, great. Thank you. Sorry about that.
I will give up control. Perfect.
Okay, this is Appears landing page. So you will need to first log in using your NASA Earth Data login account. This is the same account that you use to access Earth Data Search. So I'll go ahead and sign in here. So once you are signed in, you can submit a request using the extract option. You will see you can submit a request using area sample for a region of interest, or you can submit a request for specific point location using point sample. I will start with area sample here. So there are three options to submit a request through Appears. You can either start a new request, copy a previous request, or upload a request, upload a JSON file that contains the search parameters. So if I click one of the previous requests or drag and drop a JSON file from a previously submitted request, the form, my area sample form are going to be filled with my search parameters. But here, let's start with a new request. So here's extract area sample page. First, you will need to provide a name for your sample. So here I'm going to just say Mount Elgin NDVI area sample. For the so in Appears, you can subset data spatially, temporally, and by band or layer. For the spatial subset, you can either use this leaflet map and draw a bounding box over your region of interest, like this. Or I can upload a JSON file or a zipped shape file of my region of interest. So here I'm going to drag and drop a zipped shape file of my region of interest, which is Mount Elgin. So for the time period of interest, you can either enter the time and date using this calendar here, or you can directly type in your dates here using the given format. You also have an option to submit a recurring date. For example, if you're interested in data for a growing season, you can check this box and select the year range you are interested in and enter the months and date for your the start and end date. So here I'm going to type in my time period of interest, which is 2001 to 2018. Okay, now I have my spatial and temporal subset. I can go ahead and select my layers. So you can use this blue eye icon to view the available products. And you also can use the search bar to search for all the data products that are available in Appears. So one of the data products that we are interested in is mod 13Q1. I can directly type in the product name or short name if I know that here, and the list will filter down to show me that specific data products. Here I can see this is a Terra Modus vegetation indices. I can see the short name, the version. It is available at 250 meter spatial resolution every 16 days. And I have 2 different versions of this product available. Appears. We recently added the version 6.1 to Appears. So we have, so here I'm going to click on a newer version. And now I can see all the data sets that are available within this data product. So in this case, I'm interested in an NDVI layer. So I can click on this blue eye icon to view all the layer details. And once I'm certain about my selection, I can click on this plus sign to add that to my sample. Alternatively, you can search for a variable in this search bar. Another data set that we are interested in is land cover data product. If I type in land cover, the list is going to be filtered to only show me the data product that are having the land cover type in their description. In this case, we're interested in land cover type, which is the MCD12Q1. I'm going to click on that. Again, I can view all the layers within this data set. I am interested in LC type 1, which is an annual international geosphere biosphere program classification. I can view the layer details here. And once I'm sure about that, I can add that layer to my selection. I also wanted to note here that I can view the associated quality layer for each layer under the layer details. And Appears will return all the associated quality layers regardless of your selection. That means even if I don't add this QC layer to my selection, I'm gonna have that in my outputs. And next I have to select my output options. For the file format, I can select between GeoTIFFs and NetCDF4. And in terms of projection, I can either choose to leave all the layers in their native or source projection, or reproject all the layers to one of the projection listed here. In this example, I'm going to leave them in a native projection, and I will get a blue eye icon that I can view the native projections for my selected layers. In this case, all my layers are in a modus sinusoidal projection. Now I can click on a submit button, and a green banner will show on the top that notifies me of a successfully submitted request. I will receive an email to my NASA Earth Data login linked email. And once my request is complete, I will receive another email that includes the links to view and download my outputs. So once our request is being processed, we can go ahead and take a look at a previously processed request. I'm going to click on this Explore option, and that directs me to Explore Request page. Here, I can view all my requests. I can see my request name, the type, what is the status, what are the details for my search. And once my request is complete, I will have an access to view and download the content of the request. So let's take a look at the visualization for this request. So here's the area sample page. On the top, if I click on this drop down, I can view my search parameters, and I can be directed to download page using this download icon. If I submit, if your region of interest includes multiple features, you can view them using this feature dropdown. And similarly, if you submitted multiple layers, you can select them from here, and the plots will be updated with your selection. Below here, we are having the box plot time series for the NDVI values from 2001 to 2018. Just to make this a little bit easier to see the box plots, I will just zoom in a little bit. So each box plot represents the distribution of my values within each observation. And if I move over them, they are going to include it's going to show the statistics such as median and interquartile range for my observation over our region of interest. And below each box plot, there is a stacked chart of the associated quality values. And if I move over one of them, I can view the quality values and the decoded quality information. In this case, the blue color represents the quality value of 2116. I can see how many pixels and what percentage of my pixels are having this quality value. The date of the observation and the decoded quality information shows this value is having the vegetation index for this value is produced with good quality. The usefulness index shows lower quality with low aerosol quantity, no cloud detected, no atmosphere BRDF correction, no mixed cloud. This is a land pixel, no snow and ice, and no shadow. So if I scroll back up, I can move to the download area page using this download icon, or I can use this go back to explore page, and from there click on this icon to download the content of the request. So this is download area sample page. Again, I can view the details of the request here, and using this view icon, I can navigate back to the visualizations we just looked at. Below that, we have the supporting files such as metadata or the granule list, the text file that includes the URL for all source data used to compile this request, the README that includes the instruction and details about the request, the JSON file that can be used to recreate this exact same request later, quality lookup tables, and the statistics that includes all the statistics used to create the plots and visualization we just looked at. And below, we have our actual outputs. You can click on each one of them and download them individually, or you can select multiple or all of them. So on the top, you will be notified of how many files and how much volume you're about to download. And using this download dropdown, you can either download files in your browser or save a download list as a text file and use the wget or curl to bulk download your outputs. And let's take a look at the output I downloaded. One of the outputs that I downloaded. So this is our shapefile for Mount Elgin. This is the outputs that I downloaded from Appears. And just a note, Appears outputs, the outputs from Appears for area sample is not scaled. So as you can see, values for NDVI looks a little bit weird here. I simply just implemented the scale factor to here. So you can see that now we can look at the NDVI values in our outputs. You can see that the outputs is cropped to our region of interest and is ready for further analysis. So let's go back to Appears page. So I wanted to quickly show you how to submit a point sample as well. So if I click on extract option here and select point, Again, I have three options. You can either start a new request, copy a previous request, or upload a JSON file that contains my search parameters. So if I click on start a new request, I have to fill in the empty form. This time I'm gonna select one of my previous requests from the list, and that directs me to extract point sample page. And as you can see, my form is filled with the parameters from my previous request. Again, you will need to provide a name for your request. And in terms of the spatial subset, you can either use this little map to add points. You can add your coordinates directly here in this box, or you can modify them. You can add an ID or category for your lat and longitude coordinates. Alternatively, you can also upload a CSV file that includes the latitude and longitude coordinates for your point locations here on this box on the left. The temporal subset will be pretty similar. You have an option to submit a recurring date, and you can select date using this calendar. Here we are looking at 2016 to 2017. And similarly, you can select your layers. Here I'm looking at the land surface temperature for day and night with a spatial resolution of 1000 meter. And the data is available every 8 days. If you move over that layer, you can see that the data that layer is from Terra Modis land surface temperature and emissivity data products, mod 11A2 version 6.1 is a short name. And you can also click on this blue icon to view the layer details. I also selected the NDVI and EVI layers from mod 13A2 version 6.1, which is available in a spatial resolution of 1000 meter every 16 days. For my point locations, I selected the Lpdac location under my US category, and 2 other locations in Toronto and Winnipeg under my Canada category. So now I can just click on the submit button. So I see the green banner, so I know my request is submitted successfully, and I can move back to Explore page to view the status. So this request is pending now, and we can take a look at a similar request that I submitted before. So click on view the content of the request, and that will direct me to view point sample page. So similarly, I can view the details of my request here. For the point location, I have 3 different types of visualization under these 3 tabs: temporal comparison, layer comparison, and categorical overview. If I have submitted more than one site, I can view my locations here and select them from the list. And I can also view my layers here, or change my selection based on that. I also have an option to filter my data to only show the good quality for the point samples. And below that, we are having the time series plot for day land surface temperature from 2016 to 2017. And below that, we have the stack time series for our location. So you can select or deselect or select one layer. So this provides a comparison between years for your location. So if I move over one of these points here, that's going to provide information about that observation. So I can see the date and the actual output, what is the observed day land surface temperature for this point location for this specific date, and the decoded quality information for that. And below these 2 plots, I have a table that includes the data that are used to create these plots. So under the layer comparison, you can compare the two variables for a single location. So you can select your site, you can filter down your quality if you want to, and you can select different layers or select your variables using this two drop down, and your plots will be updated with your selection. So here we have a time series plot with two y-axis, each label with a variable that it represents. You have an option to deselect and select one of the variable if you want to. And below that, we have the scatter plot that shows the relationship between our variables, in this case, NDVI and EVI. As you can see, these two are highly correlated, which is expected. And again, below that, we have a table that includes all the data. And under the categorical overview, you can explore the distribution of your sample within categories. So you can select here I'm going to select the night land surface temperature, and right away I can see the distribution of my sample by quality. If I click on this blue icon, I can see the quality details. Here I have values 0 and 1. Value 0 shows LST produced with good quality, and value 1 shows the LST produced with other quality. So I can click on each box to filter down by that category. So here I'm going to select only the good quality data. And below that, we can view the distribution of our sample within the category of Canada and USA. If I move over this box plot, I can view the statistics for these categories. And below that, we can see the comparison between our sites. So as you can see, our Winnipeg location had a colder night land surface temperature, and Lpdac had the coldest night land surface temperature here. I also can make multiple, click on this categories to filter down to that category. If I select only the Canada, that's going to filter to show only my Canada sites here. So if I scroll back up, I can click on this download icon, and that will direct me to download point sample. Using this view icon, again, I can navigate back to the page that I was in just now. And down below, these are the supporting files, such as metadata, the granular text file, the README, and the JSON file that I can use to submit the same request. And below that, there are the actual output files as a CSV file. You're gonna get one CSV file for each data product selection. And your outputs are scaled for the point sample, and it will include your decoded quality information. Again, in a similar way, you can click on each one of them to download them individually, or you can click on this download zip icon to download all content of the request as a compressed zip file. I also wanted to mention that if you're working in Appears and you have any question, you can check out our documentation that provides step-by-step instruction on how to use Appears and Appears API if you're interested in. You can also view the available products from here, and you can contact Lpdac user services using this icon here, or you can leave a feedback, and those feedback are going to be viewed by Appears team directly. So this is gonna wraps up my the Appears demo. And I'm gonna bring my presentation back up. Okay. So next I want to talk quickly about the resources and walk you through one of our tutorials. Earlier, Daniel mentioned we have resources such as data in actions, e-learning items, and podcasts to support user. Our e-learning section contains tutorial, including R and Python notebooks, workshops, and previously recorded webinars. Our e-learning materials are created to teach user how to work with Lpdac data programmatically. If you are new to data distributed by Lpdac and are looking for resources to start with, please check out our e-learning sections. So we are going to dive into one of this Python tutorials to show you how to use Python to connect to Appear's API and submit an area sample. In the previous demo, you became familiar with Appear's graphic user interface using the Appear's API, you can access all features available in Appear's with the exception of visualization programmatically. So here I'm going to click onto the link. Hopefully this time I'll get it right. Okay. So this is the e-learning page for getting started with Appear's API area sample tutorial. On the top, you have an option to download the tutorial as an HTML that includes the text and the script and also the outputs, so you can view all those without really running through the script, and or you have an option to download the notebooks. So if you click on this Jupyter notebook, you will be directed to LPDOR Bitbucket repository, where you can find all the files, required files and information you need to run through the script. Our e-learning pages also include the markdown version of the tutorial. You can view the text and the code cells and all the outputs there as well. Here you can view the tools that are used in this tutorial and the relevant products. Here we are using the Appear's API to request layers from MODIS Leaf Area Index dataset and MODIS land surface temperature and emissivity dataset, also the digital elevation model layer from NASA SRTM. On the top, you have some introductory information about the tutorial and the purpose of the tutorial. Here, we are going to use the U.S. National Park boundary as a region of interest to extract the elevation, leaf area index, and land surface temperature data. In this tutorial, you will learn how to connect to Appear's API, query the list of available products, submit an area sample request, how to download requests, and you are being familiar with Appear's quality services, and we'll import our outputs and create some cool visualization at the end as well. So again, you can view the data used in this example, what are the topic covered here, and the dependency and steps you will need to take and requirements you will need to have before running through the notebook. So here we start with importing our required packages, set up our working environment. So this is the Appear's API URL link that we are assigning to a variable. To submit a request, you will need to use your NASA data login to get a token. This is similar to just clicking on a signing option in a website. Here we are using the get pass package to enter the username and password, and later we will use them to make a call to login services to get a token. So later on, we'll using this token to submit a request or download our outputs. You can also query the available products using a peer's API. So we can make a call to the product service and just view all the products that are available in peers. So you can see peers currently supports 155 products. Or you can also look into the information for a specific product. Here we are looking at the MCD15A3H version 6. So you can see what is the product, what is the platform, the description of the data, what is the spatial and temporal resolution, what is the version, what is the temporal extent of it, as you could view all this in the website as well. You can also search for just a variable in a data description. So you can look into, here we are looking at the data products that are having lift area index in their description, and that will going to show all these data sets here. So you can explore a little bit to see if you're interested in that specific data sets or not. And finally, we are selecting our 3 data products that we want to submit a query for. Here we are having MCD15A3H and Mod 11A2 version 6.1 and the SRTM data sets. You can also view the layers that are available within this data sets. So you can make a call to peers, a peers product service to view the layers within this, within each data product. So here we are looking at layers for Mod 11A2. These are so these are the layers. So you can see there are land surface temperature for day and night. Let's say we are interested in these 2 layers. I can make a call to view the detailed information on each layer as well. So if I just take a look at the response for the day land surface temperature layer, I can see some useful information on that. So what is the add offset value, or what is the scale factor value, and what is the field value, the description, the data type, and so on. And based on that information, I will just come up with the layers that I am interested to download or request. So I'm selecting land surface temperature for day and night for this data product, the lift area index layer for MCD15A3H data set, and the digital elevation model from SRTM. And from that, I can create a list of all the available, all the layers and the associated products here. So this is going to provide our layer subset. Next, we need to be able to submit an area sample. We also need our spatial subset. Here we are using the GeoPandas package to read in the shapefile of national park boundaries, and then from that we only select to keep Grand Canyon National Park boundaries, and we will save that as a JSON format. So that's the way we can compile it as a JSON file later on to submit a request. You can also query to view all the available projections, the similar way we did in a web interface. So you can make a call and view all the projections, and from the list, only select what you are interested. In this case, we are just selecting geographic coordinate reference system to project all our layers to that, and then we will use this information to compile a JSON object. So this is similar to filling out that form. You'll need a task name, task type, We already selected the projection. What is the output format? You can choose between GeoTIFF or NetCDF4. What is the start and end date? And if you are interested in submitting a recurring date, you have an option to do so. And using all these information, we will compile a JSON object, and we will use that JSON object to along with the token information that we have to submit our area request. So if you, you will need to make a call to the task service. We are using our token in a header and our JSON object here. And in the response, you will receive a task ID and the status of your request. This is similar as seeing a green banner. If you see this task ID, it will show you that your request is submitted successfully. And then you can retrieve your task status or your task details. You can make a call to peers task service to view the details of your request. Here we are looking at the last 2 requests I submitted using the limit parameter. So I can view all the details, and then I can also see what is the status for that specific for my last 2 requests. Or I can use the task ID that I got to look into that specific task status and view the details. So here I'm looking at my to the request, the task ID for the request I just submitted. So I can see the status of the task is pending here. And if you want to, you can make a call, let's say every 1 minute or 20 seconds to see what is the status. So the status is pending first, and then it changed to processing. And once it is done, you can go ahead and download your outputs. So again, you will need to make a call to a peers bundle API and use your task ID and your token information to get the information about your output. So as a response, you will get, this is what you get as a response. So each output that you have has a file name and file ID, file size and file type. You can use just one of these file IDs to download them, make a call and download them one by one, or you can create a dictionary that includes the file name. Here, this is what we are doing here. So you can create a dictionary of file IDs and file name, loop through that, and make a call for each one of them and download them locally. So you can also explore the peers quality service. You can make a call to quality service and view all the data sets and quality information associated to that. Here we are limiting our response to only show data for quality information for 6 data sets. You can see what is the product name, what is the layer, and what is the associated quality layer here. You can also just look, if you know what is the data sets you're looking at, data product you're looking at, you can make a call to only see the quality information for that specific data product. So you will see what is the data product, what are the layers within that, and what are the associated quality layers for each band. You can also go one step further and search for the make a query for the quality layers. Here we are looking at the FPAR LAA QC data layer. So by making a call to a peers quality service for this specific quality layer, I can view the decoded quality information for that specific quality layer. I can see what is the name, what are the values, and what each value for that category needs in terms of the quality. And you can go one step further and search for the value. So I can just look into the value 1. So let's say I'm interested to know what value 1 means in the quality layer of LA QC for data product MCD15A3H. So I can make a query and as a response, I will get the decoded quality information for that specific value. So here it shows value 1, shows in a Modline QA bit shows the other quality. Also, I can also see that there is no significant cloud detected. This is also for the Terra. They can see the sensor, which is Terra, and all the information that I will need. And finally, we are reading a raster, one of the raster outputs that we downloaded here in this tutorial, just to create a little visualization. We are using GDAL to read in our digitalization model raster layer. So we'll read that in, assign the field value, and down below, we are creating a plot of that. So you can view the final plot with a legend and title, and that you can use this code chunk to recreate your own visualization as well. So this will bring me to the end of my presentation. So if you have any questions, I'm happy to answer them. And if you have any question later, please feel free to reach out. Thank you for your attention.
Yeah, so we got a few questions coming through. That's good. If you guys have any more, I think I've answered most of them. And some of them we'll kind of cover on Friday as we talk more about the cloud transition. Some of the purpose of these resources appears in the processing scripts that we provide. I mean, it is to make life easier for our users to the extent that we can. Appears, of course, I mean, initially when it was conceived, it was like, how do we break down that 80-20 paradigm? How do we get people to do more work solving their research problems rather than having to go and find data and try to bring it together and subset it? And so I think we've done a pretty good job there. There's been a number of changes with the peers in that we've moved to the cloud, and now we're really kind of exploring what we can do with it in the cloud. Can we remove limits? Can we expand its functionality? What's kind of the next evolution of a peers? So we're actively looking into that now. The tutorials and scripts, historically, I mean, they're fantastic resources to run you through a use case on how to access the data, specifically from Python. We do have some R resources out there, so we're trying to cover those bases as well. But they are really dense, and so we're kind of looking at other strategies on making more modular type how-to guides rather than long drawn-out tutorials. That maybe a tutorial can be kind of developed off of those types of how-to guides. So yeah, I mean, really what we're trying to do is make these resources, make life for researchers easier, make it more approachable for new users to come in and start working with our data. And we're always open for new ideas. So if you have any suggestions, any corrections, or any use cases that you may be interested in us kind of working on, we're completely open. And so, yeah, Masa has the contact information out there. You could also, I mean, reach out to us directly too. We're open that way as well. But yeah, next Friday, I believe, we have more of a hands-on type demo, not really a demo, exercise where we'll be going, I mean, basically using Python to do data access, data search, work with data in the cloud rather than having to download the data. And so please join us then. The requirements that Sean has been sending out for Earth Data Login and GitHub are critical. So if you don't have either of those, please go out and sign up and pass along that information to us. I need your Earth Data Login. Well, you'll need your Earth Data Login to access data in general. I need your GitHub account username so that I can give you access to the work environment so that we all have a common work environment that we can work from. So please get that in if you haven't. And then, yeah, Friday we should have some fun.